Mitten. These are some of my favorite math stories. In this episode, mathematics is twisted. We will get out the paper and scissors and play with a geometric figure known as the Mobius strip. Although I do not know the full explanation for why things work the way they do, the results are surprising and fun and indicates that there are many great mysteries to be explored in mathematics. You should follow along with my work and try experiments of your own. All you need is some paper cut into strips, scissors, and tape. Start with a piece of paper, cut it into a little strip. I have mine at about 1.5 inches, and I marked it with stripes on one side for demonstration purposes. If I were to join the ends together, it would make a two-sided band. One side is marked with stripes, the outside. The other side is plain, the inside. And you have to cross over the edge to get from one side to the other. If I were to cut this band down the middle, it would separate into two identical and smaller bands. To form a Mobius strip, twist one of the ends of your paper once before joining the ends. Now the twist is through 180 degrees. That's about as far as my flexibility allows. So I guess technically it's a half twist, but I'll keep calling it a twist. With my paper, there's now a seamless join between the striped side and the plain side. In other words, the Mobius strip is not two-sided, it is one-sided. So what, you ask? That was my initial reaction to the idea of one-sided surfaces. Let's cut the Mobius strip down the middle. As you're cutting, ask yourself what you're expecting when you're done. Will both halves have a twist in them? Will only one half have a twist? And here's a reason why one-sided surfaces are interesting. It doesn't separate. It is just one long twisty band. You can cut it somewhere and check that the outcome has 4 twists in it. Now, if you cut this in half, how many twists will the band have? One cut, we got from 1 twist to 4. 8 and 16 are common guesses for the second cut. Now, it takes a long time to cut this in half, but the result is worth it. And now it separates. And each piece has 4 twists. What's going on? Try out a few different numbers of twists and see if you can come up with a rule for when the surface is one-sided and a rule for when the band does not separate. There are rules to be found. There are a lot of variations left in this investigation. What happens if you cut a Mobius strip off-center along the 1/3 line? At this point, you probably know better than to expect separate bands with widths 1/3 and 2/3 of the original. Try it. It separates. The weirdness continues. Cutting down the center line does not separate the strip, but cutting along the 1/3 line does. This one has a bit of an explanation. Cutting along the 1/3 line is not the same as cutting down the middle, because when you complete one revolution, your end cut does not match up with the beginning cut. So you keep going and make another cut. Remember that when we cut the strip in half twice, it separated. But don't get too cocky. This time the two pieces are not the same. The smaller piece is a Mobius strip, 1 twist. The larger piece is a two-sided surface with 4 twists. Now, I know of 2 grand finales to Mobius demonstrations. Both start with a large piece of paper with rectangles cut out to make a cross. Both will work with a cross of equal width and length, but I'll give instructions for my cross, which has a longer and a shorter side. For the Mobius frame, take the long ends, twist one and tape it to the other to make a Mobius strip. Then join the short ends without a twist. Take the larger Mobius strip and cut it along the 1/3 line. Then cut the remaining strip down the center. A little bit of shaking and you have a Mobius strip hung on a rectangle that is almost the size of the original piece of paper. That's pretty cool. For the Mobius Valentine, take one set of ends and twist it in one direction to form a Mobius strip. I put an arrow pointing downward to show that what I'm going to do with this one is take it with my right hand and rotate the top part down towards me. Remember which direction you twist the first one. I usually start this way. But then for the other end, also form a Mobius strip, but twist it in the opposite direction. So my arrow up means that I'm going to take my right hand and rotate the bottom upward. Now, I can tell you from some embarrassing failures in front of groups, you get a big mess if you twist the two strips in the same direction. So try to have your own rule for which way to do it. There's a different version online. This is the way that makes the most sense to me. Then what we want to do is cut each Mobius strip down the center. A little bit of shaking and orienting your construction, and you should have two hearts intertwined. This is guaranteed to make most of your audience go, "Aww." A little bit of time with paper and scissors can create some genuine amazement.